Howdy and welcome back. So in this video, you can see my whole desktop. I'm going to go ahead and take you through connecting to your virtual environment through Microsoft Visual Studio Code, how to bring up the terminal window within VS Code and interact with your virtual environment through text-based commands. We'll compile our first source code here together, and then we'll run through the motions in terms of the process that I expect you to follow when you're working on, say, an MP, a lab work, or otherwise. So I'm going to come down here. You can see I got a bunch of stuff open. And we're going to go ahead and create a new window with our Microsoft Visual Studio Code. So I'm going to go ahead and open up our command palette again, and I'm going to remote SSH into my virtual environment. And remember, at this point, I don't know where I move my face over to the side so you can see this. Again, I was assuming that you've booted up your virtual environment at this point and it's ready to be connected to. So I'll go ahead and log in as Vagrant at 127.0.0.1, and we're hitting port 222 on that. That new window opens up here. It's asking us for our password, again, Vagrant, and we're up and running. Now, in order to interact with the file system of our virtual machine, we're going to come over here to this Explorer window, and we're going to open a folder. For the purposes of this exercise, I'm going to go ahead and connect to our source folder, which is that shared folder between our local machine and our virtual environment. So any files that I create there will be accessible through the Finder window or the File Explorer on my local machine. I'll click OK. And we'll see here that if we were working on, say, a different assignment, like maybe assuming Howdy World was the directory for some sort of Howdy World MP, we would have opened up that folder instead. But we're going to go ahead and start just from the source directory. The reason why I'm doing this is a lot of steps kind of in the process is going to be first going ahead and connecting to our virtual environment in VS Studio Code, and then thereafter we would run some operation which would essentially clone starter code from a Git repository. We'll get into what all of that is later in the week, but just understand we're actually going to have to pull down the starter code for our assignments, which will provide us with the directory for that assignment from which you will continue crafting or composing your solution to that particular MP lab work or otherwise. So you should have had a terminal window open up down here. If you didn't, you can hit the terminal menu from the taskbar here, and you would just go ahead and click New Terminal. Now here, I'm able to interact with my virtual environment in a text-based manner. So if we look at our location here, and again, this will display a little bit differently if you're in Vagrant and not in Docker, we can see that I'm in my tilde, so home directory, and within the home directory, I'm in the source folder. So if I go ahead and write pwd, I can confirm that. Home Vagrant source. If I type ls, it's listing the contents of that directory here. And notice that everything that I showed you on the previous video, you can do here within this embedded terminal window within the Microsoft Visual Studio Code editor. So this is pretty cool. Perhaps we want to go ahead and compile our first, I think you've done this before. Hopefully you've done this before when you were setting up your environment, but let's just go ahead and do it again. So if I wanted to compile hello world.cc, we're going to use Clang++. That's the C++ compiler we're using. We're going to use the C++20 standard. In the documentation, there's a couple of other flags that I'll expect you to pass to the compiler to go ahead and kind of observe warnings that it issues as errors in terms of, in other words, things that we're going to require you to correct before the autograder will accept your solution and actually run our test suite against your code. We'll get into that a bit later, but that would be if you're compiling fine locally, but you go ahead and submit to the autograder and it says, hey, your program, failed to compile without errors. We'll go back and look at those flags attempt to compile with them and then see what Clang is complaining about. But here, let's just keep it simple. The name of the source file that I'm going to feed into the compiler is just hello world. I'm going to go ahead and hit enter. Notice up here in the left-hand side, we can see that a new file was created, this a.out. It wasn't there before. That is the default name of the executable generated by the Clang compiler. In this case, what I mean by executable is a program that we can run. And if we go ahead and run it, we'll do // the name of the program that we'd like to run, a.out, click enter, and we can see hello world printed to standard output. And if we go ahead and open that file here, we can see that, well, okay, let's decompose this. We're including a IO stream library, probably going to be doing some sort of IO. And if we look at our main function, our entry point into a C++ application, we can see one statement there where all we're doing is simply inserting hello world to standard output, which means it is getting displayed within our terminal window here. Okay, cool. So let's go ahead and remove that file, that executable that was just generated, rm a.out. And we can confirm that it was indeed deleted by writing ls again. Let's say I wanted to give the executable a more informative name. And if you notice here, I'm using the up and down arrows to navigate through my history of previous commands that I've issued. This just makes it a lot easier to get back up to this compilation command that I literally just used instead of having to type it out again. Anyhow, so focusing back down into the compilation command presented here, if I wanted to give that executable a more informative name, I could go ahead and provide the output flag, which will be the name of the executable to be written. And I could do hello world. I mean, you could provide an extension .out if you wanted to or not. I'm not going to. Here, I'll click enter. You can see here a new file is present in our source directory, hello_world. That is an executable. It is a program that we can run, and I can go ahead and run it by // name of the executable, hello world, and boom. We can see hello world is again printed to the output. Okay, so let's go ahead and remove that again. rm hello world. Be careful to not write hello world.cc. We don't want to lose that source file. So I'm just going to remove the executable and you can see it's gone. Okay, let's say that Howdy World is an MP that we'd like to work on. And what I've kind of been trying to communicate here is anytime we're working on an MP lab worker, otherwise we want kind of the MS Visual Studio Code window to be opened in that directory. So it's kind of like if you have a number of different folders, files within the source directory, we don't want to look at any of that. We only want to look at Howdy World. And the reason for that is going to be that we have some configurations, which it's going to be imperative that the MP folder is kind of the base directory of the window that we're operating under. So I'll go ahead and go File, Open. And we can see here that this open file or folder will again display. And I'm going to click on Howdy World and press OK. And we can see here that a new window will open. It's bound to the Howdy World directory. And if we go ahead and look here, notice that we're only seeing the files associated within that directory. It's kind of the base directory from which Visual Studio Code is interacting with our virtual environment. And notice, in the previous window, which seems to have disappeared, you could see pretty much everything within that source directory. So anyways, we're here. We can see that the window is, we started out in the source folders, Howdy World folder. And again, this is how you'll be opening up every MP lab work or otherwise in this course, should you want to work on it. Okay, cool. So let's go through this directory structure very briefly. And then I will just simply add on a little bit into the compilation command and we'll close out this video. And we'll pick right up where we left off. and I'll introduce the line-by-line debugging. But okay, let's say I want to compile my howdy world. We can see here, and if you think back to the lesson where we introduced functions, I have a utility header file here, which provides some declarations. Well, in this case, for a single function named howdy. It's going to be a function that returns a standard library string whose parameters are is a single string. And we'll get into what this ampersand and const means at a later point. The definition for that file, for that function would reside in the utilities.cc source file, which again is the corresponding source file to that header file. And we can see here this function doesn't do anything too interesting outside of some basic string concatenation. So running through this, I realized I got ahead of myself a little bit. So what are these directories? Okay, Ben is where all of the executables will go. So if you're compiling by hand, by writing out the compilation command in the terminal provided to you in VS Studio Code, we're going to want to make sure that that executable ends up in Ben. And for all of the programs that you're writing in this course, we're going to want that executable to be named exec. Okay, so that's where the executables are getting routed to. Includes is going to simply be a directory which is going to contain all of the header files that you've composed. Source is going to contain all of your source files. So notice here, all .cc source files are in the src directory. All of the header files with the .hpp extension are in the includes directory. So if we go ahead and just look at the contents of howdy world here, you can see there's a directory named includes, contains the header files, src, which contains the source files. And what we will get into later in the week is we're also going to have a folder named test, which is going to contain a file named test.cc, where you'll define your unit test for your particular solution. You can see here, and again, don't worry too much about this yet. We haven't introduced the Catch2 framework just yet, though we will a little bit later in the week, and you'll be able to hopefully effectively craft your own unit test for your solution. And what we'll see here is one of the nice things about what we'll see shortly is one of the nice things about writing test cases or a test suite for our programs is it's very easy to run all the test cases by simply compiling our test suite and executing it instead of like compiling our program and trying to feed into it, some number of different combinations of input and then manually inspecting whether the output matches up with our ground truths. But again, we'll get into the test suite a little bit later, but let's go ahead and just compile this. So I'll do the naive approach first. We're going to see some complaints here. So Clang++, this version of C++ that we'd like to use is C++ 20, the 2020 standard. And I'm going to have to compile the source files. In the compilation execution lesson, we'll get into how each source file is fed through the compiler, but we're going to have to list each of them. And those source files are going to be provided to the compiler with their relative path. So .forwards, and again, it's relative path because look where I am. I'm in the root of this kind of project directory. So the root of my MPs folder, the root of my LabWorks folder, what have you, because that's how we set this up. We open that new window, which was opened with the folder of the project that we were interested in working on. Okay, so that means that the source file that we'd like to feed into it is not in the current directory we're in, it's in the source file. So the relative path to that is going to be ./source, and then we're going to provide howdyworld.cc. And then, we could go ahead and attempt to compile this. There are going to be errors. The first one is that it's going, hey, the header file that we're looking for in howdyworld.cc cannot be found. The reason for this is where Clang is looking for our header files is first in the current directory, which is that. It is not our includes folder. So we have to tell Clang to go look in includes. And to do that, we're just going to add an additional flag, uppercase I, and then we'll write down includes. That is the directory which contains all of our header files. And this -I directory flag is telling the compiler, hey, look in the includes directory for the header files. So if we go ahead and click enter, we're going to see a linker error at this point. And we'll get into all these sorts of fun errors that can arise a little bit later in the course if we haven't already. But the reason why this presented is that, okay, we compiled howdyworld.cc, and the next step in the process was kind of to link up the different source files that we've compiled together and to bundle them into an executable. And during that process, what this fun looking command is saying is, I did not find a definition for this function. And the reason why a definition was not found for this function is because we did not compile utilities.cc, which contains the definition of howdy. So how do I go ahead and provide that? Well, not only do I want to pass in howdyworld.cc, but I'm also going to pass in utilities.cc. I click enter and we can see here, there are no errors. The source files here were compiled successfully into an executable. However, notice where that executable ended up. It's in the current directory. And we said we want all of the executables to be routed into the bin directory. So I'm just going to go ahead and remove that and add the output flag and specify where I would like my executable to end up, which is going to be in the bin directory. And we said that whenever we're compiling our program, so that includes the main, the source file with our definition for this main function, we're going to go ahead and call that exec, E-X-E-C. If I go ahead and click enter, we can see over here on the left-hand side that the bin directory has a new file. It's a executable named exec. Now to run that, again, look where we are. We're in the root of our Howdy World folder. So if I'd like to run exec, it's going to be a relative path to that executable. /bin exec. That's the name of the program I'd like to run. Enter, and well, howdy Michael. Okay, cool. So that's kind of taking you through the process in this course. Pretty much from this point forward, all of the MPs are going to be provided to you with a non-flat directory structure. That means when you open up the root of, say, a particular MP's folder that you've cloned the starter code for, you will see a bin directory. And again, that's where the executable is going to have to make its way to. For the application, name it exec. For the test cases, we'll see here and later on that it will be named, leave tests, plural. But let me double check that. Yes, plural. Okay. And then you'll see this includes folder. And if we ask you to create any header files, it should go into that directory. If we don't ask you to create any, the starter code header files will be provided within that directory. All of these source files will be found in the source directory, src. And then we will be expecting you to submit test cases for each of your MPs. You would go ahead and author that test suite in the test directory's tests source file. And we'll give you some information on how to compile that test suite a little bit later into the week. So anyways, I hope this is slowly coming together. Some things that I did not show you were the kind of the grammatical checks, similar to what you'd observe in Microsoft Visual or Microsoft Word as you're writing, say, English or in your native language, and different suggestions that can arise there. We have something simpler within, or something similar in VS Code set up for you. So as you're composing your solutions, you will see the squiggly lines with not only recommendations, but also things that should be corrected. And this will help you author your solutions better towards using best practice. So anyways, let's go ahead and move on to the line-by-line debugging video. I know these lesson videos for today might be getting a little longer. I'm rambling now. My apologies, but yeah, we'll get into the line-by-line debugging here in the next video. And I will go ahead and say that this is probably one of the more beneficial things that we've recently incorporated into the course. And it will allow you to essentially, when we ran, say, my Howdy World, this project that we compiled here, it just ran all the way through. With the line-by-line debugging, you can essentially step the execution line by line and look at the overall kind of state of your program at that particular instance in time during its execution. And this will be invaluable when it comes to debugging your source files and tracking down errors. So with that, I'll see you all in the next video.